You should be able to share. You should be able to.
Can you see my screen? That is the so I will get started. So I would like to first thank you for Professor for adjusting time for me. So today I'm gonna give out a presentation on the topic interpretability of a supervised learning-based trading strategy. So here is my agenda. Firstly, I will give an overview of our research topic, and then I will introduce our research findings. Moving forward, I will specify what's my accomplishments over this semester. Next, I will introduce methodologies. I divided it into two parts. For the technology part, I introduced the code I used to achieve my accomplishment. And for the resources part, I just briefly introduce what I gained knowledge, where I gained knowledge from. Next, I will share some insights on what I learned from this research experience. Finally, I will draw the conclusion. So here is a brief overview. Our research is aiming to solve the black box issue in the learning system. It is in between the input and output and happens when the computing system that are used to solve problems is not that clear. So it poses risks such as possibility of bias and lack of trust. So our research goal is to improve the interpretability, which defined as the degree to which a human can understand the cause of the decision of a machine learning algorithm. We use different tools to achieve that, including sharply addictive explanations, LE5 explain like IM5, and LIME, which is what I focus on, the local interpretable model agnostic explanations. And our focus is to predict the price of Bitcoin depending number of features, and we use historical data of Bitcoin from past 10 years as our base model. So our research finding is among the top 10 features from 3 models are common in all 3. That is, they share a lot of similarities and the result is consistent. So in this part, I will elaborate what I have done for this research. I first divided it into 6 parts. I prepared data first by cleaning non-variables. And for the data partition part, I split the data set into training and test sets. And then I performed the feature engineering by adding features that may influence the performance of the prediction model. After that, I applied the LIME, which creates a surrogate model locally around the unit. Finally, I visualized data to gain some insights about data. And with that, I attended the Quant conference at Lehigh and the Wall Street Council. So in this methodology part, I will specify how I achieved those accomplishments. So for the data preparation part, after I clean the non-values, I calculate long and short moving averages and signal variables. Later, for the data partition part, for the training data, it is for training the machine learning model use a supervised learning method. And for the testing data, it is for just checking the accuracy of the model. I also have the flow chart over there to show how I prepare this model ready for use. Then I applied the LIME model. So LIME is a novel explanation technique that explains the prediction of any classifier in an interpretable and faithful manner by learning the interpretable model locally around the prediction. And for the feature engineering part, I also add a lot of indicators, including moving averages, as I mentioned before, and a stochastic oscillator percentage K and percentage D, which compares the closing price of a security to a range of its previous price over a certain period of time, and the relative strength index, which measures the magnitude of recent price changes and the rate of change. So here is the data visualization part. I have the histogram, correlation matrix, and the explainer dashboard. Here are some resources that I access over this semester. The first one is the machine learning in finance. That is an online course designed by Heron. It gives me a deeper understanding of concepts and the most in-demand skill set. I think it is really useful. And I also refer a lot the textbook, the machine learning and data science blueprints for finance. There is a case study contains a lot of information about Bitcoin trading strategy. So I benefit a lot from it because there are a lot of details about how you perform the feature engineering and what feature you should add on and what do those features mean. And Data Camp, of course, that is a strong online learning platform for leveraging my skill set. And for the GitHub and Stack Overflow, at the beginning of the research, I collected a lot of resources code from GitHub. And during the process, if I got some error message, I will find the code error solution on the Stack Overflow. For in-group meetings, our group basically meets every week. So I think it is really helpful for me to share my progress and insights with my teammates. And for the weekly meetings, I just reporting my updates throughout the semester to you, Professor Zorro, and Bill. I think it is really helpful for me to keep track of the process and be mindful to complete tasks on time. So here is a high-level overview of what I learned from this research. Specifically, Python skills. I learned a lot of it. Of course, I think it is really useful and I can bring out of this research because it is one of the most in-demand skills and can be applied in a lot of fields. And I have gained more exposure to trading strategy through feature engineering. For example, by comparing those feature values to calculated prediction possibilities in the explainer dashboard, I can better understand the model and simulate a trading strategy using historical data. And in the bigger picture, I have a deeper understanding of application of machine learning for better decision making, because with the help of machine learning, I can identify trends and patterns, enable automations and a continuous improvement in the future. I think machine learning is really useful for a lot of big firms to smooth their business progress. So with that, I draw the conclusion. I always ask myself what I can bring out of this research experience. The first is teamwork, because a majority of time we work in teams, so I have to communicate with my teammates a lot to make sure we are on the same page. And if someone got some difficulty in solving a particular problems, we can help each other. And for the time management part, sometimes I got a lot of things coming up together, so I have to make the priorities to make sure I complete each of those tasks on time. I think it requires a strong multitasking skill sometimes, so I've really learned this new skills this semester. And for the problem solving part, I think this research experience is not like the traditional course. You don't have like a specific meeting time periods, and a lot of times you have to figure out the particular problem yourself. So you have to do a lot of research, and sometimes there are a lot of ways you can solve this particular problem, and it is your job to find the best and the most efficient way to solve it. And last but not least, the research. I think I am not merely coding. I have to understand the algorithm and the implications of this coding. I have to know why I'm writing this line. So I have to read a lot of research papers and do a lot of internet search online. So I think that is the value. So overall, I think it is a valuable experience and benefited me a lot. And I learned a lot of technical and soft skills that I can bring to future. So Thank you for your listening. That is all.